We're going to use a technique of integration called the method of partial fraction to evaluate the integral of the rational function 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 squared. Okay, first we have to check that the degree of the numerator, which in this case is equal to 3, is strictly less than the degree of the denominator. But when we look at the denominator, x squared plus 1 squared expands. The highest term, the highest power of x we get from there is x to the fourth, and then times the x. The degree of the denominator is 5, so in fact it is true. The degree of the numerator is strictly less than the degree of the denominator. We can now proceed without having to use long division. We're now going to do the partial fraction decomposition of this rational function 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 squared is going to be written on the right as a constant over the only linear term x. So a over x plus a linear term of the form bx plus c over x squared plus 1 to the first power. Notice that x squared plus 1 is an irreducible quadratic polynomial that's repeated twice, so we're going to need another linear term dx plus e divided by x squared plus 1 squared. And now multiply everything by the denominator from the left. We have 1 minus x plus 2x squared minus x cubed on the left. A over x times x squared plus 1 squared will be a times x squared plus 1 squared plus bx plus c times x squared plus 1 to the first, because one of the powers cancels, and then times x plus dx plus e times x. Now when we look at the right hand side, we see that plugging in 0 for x will be helpful. That gives us 1 on the left side. On the right, the bx plus c term and the dx plus e term will be 0. Plugging in 0 for x, 0 squared is 0 plus 1 squared is 1, so a is equal to 1. We found one of the constants is 1. Let's rewrite the left hand side as follows. 0 times x to the fourth plus negative 1 times x cubed plus 2 times x squared plus minus 1 times x plus 1. And on the right, since a is equal to 1, we expand x squared plus 1 squared. That gives us x to the fourth plus 2x squared plus 1. Bx times x squared is bx cubed times x. That's bx to the fourth. Bx times 1 is bx times x is bx squared. Cx squared times x is cx cubed, and then c times 1 is c times x is cx, plus dx squared plus ex. Notice that 1 and 1 cancel, 1 on the left and 1 on the right. Let's rewrite then the left hand side as 0 times x to the fourth plus minus 1 times x cubed plus 2x squared plus minus 1 times x, and on the right, coefficient of x to the fourth, we have a 1 and then also a b, so 1 plus b times x to the fourth plus the only coefficient of x cubed is c, cx cubed, plus the coefficient of x squared, we have 2 plus b plus d times x squared, and the coefficients of x are c plus e. And now let's match the terms. 0, which is the coefficient of x to the fourth on the left, must equal to 1 plus b, and that gives us b equals minus 1. Then we have the only coefficient of x cubed on the right is c, and on the left it's minus 1, so c must be minus 1. Then we have coefficient of x squared on the left is 2 equals to 2 plus b, b is minus 1, plus d, so 2's cancel, and therefore d must be 1. and the coefficient of x on the left is -1. On the right it's c plus e, but c is -1 plus e, and that gives us e equal to 0. So we found all 5 of the coefficients a, b, c, d, and e. Let's return to the integral. The integral looks like this. We had the integral of 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 squared. Now it's equal to a divided by x. A is 1, so that's just the integral of 1 over x, plus the integral of bx plus c, that's minus x minus 1 over x squared plus 1, and then plus dx plus e, that's just x divided by x squared plus 1 squared. Now let's rewrite this. This is the integral of 1 over x, that's ln of absolute value of x, minus the integral of x divided by x squared plus 1, minus the integral of 1 divided by x squared plus 1, plus the integral of x divided by x squared plus 1 squared. Let's this integral again is known, so we have ln of absolute value of x minus integral of 1 divided by x squared plus 1 is inverse tangent of x, minus the integral of x divided by x squared plus 1, plus the integral of x divided by x squared plus 1 squared. Now we can do both of these integrals by the same substitution. Let u be x squared plus 1. Du is 2x dx. So 1/2 du is x dx. And when we come back to these integrals, we have ln of absolute value of x minus inverse tangent of x minus x dx is 1/2 du, and this is 1 over u, and then plus 1/2 du 1 over u squared. So this is equal to ln absolute value of x minus inverse tangent of x minus 1/2 ln of absolute value of u, and then the integral of 1 over u squared is minus 1 over u, so this is minus 1 divided by 2 times u, and all we have to do is replace u with x squared plus 1, so the final answer is ln of absolute value of x minus inverse tangent of x. Since u is x squared plus 1, there is no need for absolute value, so this is 1/2 ln of x squared plus 1, and then minus 1 divided by 2 times x squared would be 2x squared. 2 times 1 is 2, and we can add a constant of integration at the end. That's the final answer.